So, hi, good afternoon to everyone. So we've heard about 3D printing and the technology of 3D printing, and we've heard about the education. I think my job in the next 10 minutes is actually explaining how 3D printing is actually being used in the industry, and especially in my organization. My name is Gerada. I'm the procurement and IT manager at Trelleborg Group. Trelleborg Group is a Swedish organization with around 120 manufacturing sites all over the world. We have around 23,000 employees, and we are world leaders in engineering polymer solutions. In a very simplistic term, that is engineered rubbers. Okay, so anything that we do with rubber, that's us. We focus on three main areas, which is sealing, damping, and protecting. So sealing, it's anything related to, we're basically responsible, for example, of the hydraulic lines that connect your braking systems in your car. When it comes to damping, we are in almost all areas in as well, things like, for example, for you to have a smooth ride on a train. So underneath the rails, there are damping solutions which gives us a smooth ride during the train and lowers up the acoustics as well. And protecting. So another example of that would be, for example, the piping and the hose systems for the fire extinguishing systems. Few market segments, we're pretty much into many different markets, really starting at the top with the aerospace business, automotive, marine systems, we're in the medical, oil and gas as well, and even underneath, so under subsea level in exploration sealing as well. Now, 3D printing, that's something really simplistic on Trelleborg, really quick, but now 3D printing in Trelleborg. First and foremost, I cannot mention 3D printing, and we're actually in Malta, without mentioning the facility we have in Malta. We have a manufacturing site, which is on the south part of the island, in exactly Halfar, very beautiful place, in actual fact, very close to the sea, as you can see. We produce O-rings and engineered molded parts for the automotive and industrial areas, but we're getting into the healthcare and medical as well. But mostly important as well with the subject of today is that we are actually the lead site for 3D printing for the whole Trelleborg group. And this is just really quick one, a video to show you the laboratory of 3D printing here. This is really a quick glance of basically our 3D printing laboratory that we have in Malta. Very simplistic. Keep in mind, we do rubber. So our core product is actually rubber. And 3D printing of rubber does not exist. So we cannot actually produce our own parts using 3D printing technology up till today. So in reality, 3D printing, it's more of an add-on. It's more of a tool for us. And I'm going to give some purely few case studies of where we actually use 3D printing in our business. So the first category is for us is parts for manufacturing, for machine development, because we deal so much with a huge amount of volumes. So for example, in the facility in Malta, we are 550 employees. We produce approximately 25 million O-rings a week, and each and every part, single part, is actually fully checked from the different type of areas. So we have to handle all of those, not with man labor, but in actual fact with full automation. So we have the capabilities of designing and creating our own machines internally. So automation, robotics, and all these sort of stuff, we have a specific team that actually does that. So what happened is that for many, many years, obviously, the design and creation of these machines were predominantly being done on metal. But with the introduction of 3D printing, that's changed a little bit the mentality. First and foremost, anything that you see in yellow there, that's 3D printed. So those are actually functional parts which have been designed and manufactured specifically for machines that we've built internally, but they are completely 3D printed. Giving you an example, this is an example which has been printed, and it's actually used, a manifold that is being used on one particular machine. The main advantage that they give us, and I'm going to put some figures, 3D printing in this particular case gives us, first and foremost, the lead time to be able to do something like this in metal. It takes you around 2 weeks between availability of capacity and as well the designing. You can only have one opportunity to do it in metal because it's going to cost you a lot of money to do it. This will easily cost you around 100, 150 euros to actually do it. Notwithstanding, you think about when you start to manufacturing this in metal, this is a block of metal which needs to be drilled. Okay, whereas in 3D printing, this is completely different. You start building it from the bottom upwards. And this is a particular case whereby we needed to build a packaging machine for our seals that need to be packed into anti-static tubes. This is an automotive customer. And we needed holders, specific holders for these tubes. So what happened, the engineers had the opportunity to have multiple design iterations. So they designed the product a couple of times. They printed it. It didn't cost them anything. And they actually chose the right product. It took us from 2 weeks to 3 hours of printing, and from 65 euros, it actually cost us €1.79. So the benefits, the cost benefits were incredible. And this was with the first printer they've actually introduced. So what happened to us is that we started buying new machines and new printers. Now, another important category for us, which is simplistic, but it's great for commercial aspects, we call them the show and tell samples. And the show and tell samples are basically, we produce very small parts. And most of the time, you are actually dealing with a customer who has a drawing in front of him. You're doing on a new design of a fuel injector, and you're trying to talk to him. You're trying to make him visualize that particular product, basically on a drawing. What do? We actually print that drawing in plastic. We magnify it by ×10 or ×20 to enlarge it as much as possible and go to a customer with a plastic part, so it's not functional. But we can talk to him about the safety critical areas, certain specifications, and certain designs. And that is always very helpful when it comes to a commercial aspect. I'm going to jump a bit from one division to another, Trelleborg Marine Systems. Here we do fenders systems, buoyancies, and undersea level for the oil and gas business. What do? Instead of having, we still have a drawing that we need to discuss, but we are actually creating fenders, which are massive, they're big. So instead of having something which is big, which we obviously can't show to the customer, we actually print a 3D design of his fender, and we can actually talk. Sometimes we actually print the whole port for the customer to can actually visualize the whole process. And that really works well with the customers. Another important aspect, another division, complete division, Trelleborg does agricultural and industrial wheels. Unbelievable the amount of engineering that goes around an agricultural tire. And one most important thing is, and believe it or not, you sell tires based, yes, on their energy efficiency and how much damage they do to the crops. But mostly important is that the customer is really interested in how aggressive the tire looks. So what do we do before we go to market? When we design a new tire, we 3D print a tire, and we go to the customer and get a feeler of the market. What do they think about this new tire? So, last couple of things, prototype and functional parts. We're in the business of pipe seals as well, so drainage pipes, sewage systems, and all these sort of stuff. Most of the time, these products are massive, really big, very difficult to transport. So when we need to design a particular seal for these pipes, what we do is we basically print a section of the pipe, which is easier for us rather than transporting it from all over the world. And that's a very important aspect. Another important aspect is that here we actually produce extrusion dies. The method that we create those seals there are extruded from a particular machine, and you need a die to give it its shape. So what we do is we actually 3D print this in particular in metal, extrusion dies, which you need very skilled labor to do it, which is not available any longer. And it takes you half of the time as well to do it. Last option, we also do profiles for window seals for skyscrapers, so that is under profile systems. And we 3D print extrusion dies. And these extrusion dies, exactly as you can see, actually are, again, very skilled to be, you need a very skilled laborer to do it, and very difficult and complicated to manufacture by hand. So what we do, we 3D print that. And that's changing the completely way of our manufacturing processes. So last slide on the future. What we're looking as more industrial, we're expecting more industrial grades to come along, so more complicated plastics, which will give us more advantages. We are expecting, and we're working on a development program to actually do prototypes in rubber printing, so really printing rubber straight away, our own product, without any other, or literally printing the product itself straight away out of a printer. And the last thing, but most important, is actually the topology optimization, complex designs, which we've already mentioned in my previous presentations, which are more complex, designing a complete different mindset. And this is where I think startups can come and do a big play, whereby there is a big, we're just touching the surface here with 3D printing. It's really all starting. Industry is being accepting now. So what's happening is that there is a great opportunity for startup to start looking at topology optimization and other areas into 3D printing. So with that, thank you very much for listening.